here gives us the average salary for a church pastor across the U.S. that increases as the size of the church increases. And so this should kind of make sense for this particular position because churches generally are not profit driven, right? So whereas you might see more of a linear relationship if we were looking at like a company where as the worth of the company goes up, the CEO gets paid more and more and more. There's no cap on pastor salaries. There are a few out there driving Lamborghinis. I, for one, would not really want to go to that church if my pastor is out there serving the Lord in his Lamborghini, but you may have a different opinion on that. But in general, a church pastor is a job that, the pastor is not going to take an astronomical salary, even if it is a super big church. Now, they'll probably get paid more than somebody at a tiny church, but you're not going to see that just take off, right? Like you might in other jobs. So it kind of makes sense here that this starts to level out. Whether you got 5,000 members or 20,000 members in some, well, I would consider both of those pretty mega churches to me, but whether you got that many, you're not going to increase that much in your salary there. So we can see this pattern right here, and what does that look like to you guys? What type? That looks logarithmic right there. Exponential would be like the flip of that. It'd start off slow and go up quickly. So this is going to be like a logarithmic pattern. In a logarithmic pattern, it starts off really fast at first, and then it grows slowly after that. And this would kind of make sense. Like a little tiny church is going to have a hard time paying their pastor. A lot of pastors are basically volunteers that don't get paid hardly anything at very small churches versus bigger churches versus mega churches. You're going to see that sort of happen. We're going to start off with what I call sometimes like a naked problem that has no context, and then we'll work up to our church pastor problem next. So log function models are given either in the form y equals a plus b natural log of x, or y equals a plus b log x, where a and b are constants. So this type of problem, if you think about those free response questions that you had on the midterm and the ones you had on the exponential test, this is a function type that they might give you on that free response question. So they might give you an exponential like you've already seen, but they also might give you a log function. So it tells us here selected values of the log function are given. Use the data, given data to write two equations that can be used to find the values of constants a and b in the expression for L of x. So this is just like you're going to see on a free response question. It's guaranteed it's going to be in your test. It will probably be in context of something, but it'll be that same type of question. So if they give you a log function here, you just need, in this first step where it asks for two equations, you're just plugging in your points, right, to whatever your model is. So we got the point 2, 3. That's going to look like this. 3 equals a plus b natural log of 2. And then we are going to do the second equation with 5, 7. That will be 7 equals a plus b natural log of 7. 5, sorry. Thank you. Okay, so for this, if they ask us to find the values of a and b, on some of these you would be able to find the value a little more easily. This one would require a like system of equations. Oh, maybe I don't know. Do I want you to do it? No, I don't think so. So we're just going to use Desmos for this. We don't have a lot of time, so if your computer's not up, you can just watch what I'm doing here. Good gracious, look how many things I've got open.
What would you do first? Or are we just going to like plug it in?
I would just plug it in. 2, 3, 5, 7. Let's see if it's an option here. Let's see what logarithmic does. This would be fine for logarithmic because notice it has, I gotta make it a little bit bigger here. It's got natural log of x. So it would be okay on this one to use the logarithmic regression because it is natural log. There's a chance they give you a log with a different base or they give you a log like a different type of equation. So it's, always an option here just to take this and do y1 squiggle instead of L of x, a plus b natural log x1, like that. You'll get the same numbers whenever you do that. So whenever we do this, we get a is equal to negative 0.0258832. AP only requires 3 decimal places, but if you're using it for something later, you need to keep all the decimal places. And then B is 4.36543. Okay, questions there? Very similar to what we did with the exponentials. We're just doing log equations now instead of exponentials. So let's move on to our church salary problem. So again, we're short on time. If you got your computer up, you can type it in, or you can just watch what we're doing here. So we've got our data entered, and then it tells us here that we're supposed to use the regression capabilities of your graphing calculator to find a logarithmic model for the data above of the form S of P equals A plus B natural log of P, where P represents the church size and S is the average pastor salary in thousands of dollars. So it is A plus B to the times natural log, so we can just use the logarithmic regression. One thing you do want to do, they gave you specific variables, S of P here. So use that instead of X and Y. So do S of P equals negative 91.54204 plus 29.90882 natural log of, use a P instead of an X. Oh gosh, probably. I'm not using the... No, I don't think it changed it actually on this one. Good, because I've already written that down. Alright, B says using the model found in part A, what is the predicted annual salary in thousands of dollars for a pastor whose church size is 500 people? So first of all, they are asking us using the model found in part A. So even if 500 was already on this table, we would not use that. We're plugging it into the equation. And to show this, because on these it's going to be a calculator active free response if it's free response, but you've got to show what you're doing. what you're doing is you're plugging in 500 for the x, or in this case the p, right? To do that, I would do s of 500. Technically, you don't really have to do anything else right there. You can just say equals. If you want, you can do negative 91.54204 plus 29.90882 natural log of 500. Now, what I would actually do to calculate it is I would go over here to my graph and I would just put x equals 500 for that graph. I'll zoom in a little bit here and see where we cross. And I'm getting 94.32954. But now let's think about what we're talking about. Does that make sense? What am I missing? $94 for a pastor seems. It's thousands of dollars, so it's going to be 90. Well, actually, it says in thousands of dollars. So what I could just do is say $1,000 here. What I would prefer is 94,329.54 for that. Okay. These questions are very similar to the ones we did for exponential as far as like the types of things they're going to ask you. It's just the equation you're dealing with is different. Okay. The last one that they have us looking at here is a very common usage for log functions, and that is sound intensity, which is measured in decibels. We talked about that just very briefly whenever I introduced this. So the most common and preferred method to measure sound intensity levels is in decibels. The sound intensity level beta in decibels of a sound having intensity I in watts per meter squared is modeled by the function, and it gives that there, where A and B are constants. The sounds of noisy traffic has an intensity of 1 times 10 to the negative fifth watts per meter squared and corresponds to 70 decibels. A loud concert has an intensity of 1 and corresponds to 120 decibels. Again, this is written very much like part of that free response question. So for A, it says, write 2 equations that can be used to find the values of the constants A and B. So we're going to take this equation right here, and we're going to plug in the 2 values that they gave us. So the first one that we're plugging in has an intensity of 1 times 10 to the negative fifth and a decibel rating of 70. And this right here is your decibel rating. The I is your intensity. So I'm going to have 70 equals A plus B log of, because it's 1 times 10 to the negative fifth, I could just do 10 to the negative fifth right here. And then I want to do that same thing for my other point that they gave me. I've got a loud concert with an intensity of 1, and it corresponds to 120 decibels. So that would be 120 equals A plus B to the log 1. Now, I'm going to show us how to do this both by hand and see if the calculator will do it. I think it will, but there's a chance it may not like that 10 to the negative fifth. So I got 10 to the negative fifth, 70. And I've got 1 and 120. and I want to do a log regression here. And it looks like that is working just fine. There is a way to actually solve this one by hand that I would like. Oh yeah. Oh, thank you. Yes, it's not working because it's natural log of x. And I don't think logistics is a whole different thing. It's not, so, oh, yeah, let's not do that. So this is not going to work because it's natural log. The 120 is actually still right. But what should I do instead, since this is log, not natural log? Y1 squiggle. X1. Yeah. So the I is really like your X right here, and you have to put an X1. And then the beta of I is like your Y1 here. So I am getting an A of 120 and a B of 10. Now, let me show you how we could do this by hand as well, because some of you might prefer it. It's like a little more reliable because you may, like a lot of you guys got the one wrong on the test on the midterm because you used the straight regression and you couldn't do that. It was like divided by 12. So if you solve it by hand, you might avoid that issue. So what is log of 1? It is 0, which means 120 is just going to equal A, right? Because B times 0 is going to be 0. So if we take that and plug it into the other problem, we've got 70 equals 120 plus B log of 10 to the negative 5th. What is the base on a regular log? 10. So the 10's cancel right here. So I've got 70 equals 120 plus B times negative 5. Well, that's just a regular equation I can solve, right? So I can subtract 120. I will get negative 50 equals negative 5B. And I will divide by my negative 5. And B equals 10. So it's not too bad to solve that one by hand. You might avoid accidentally doing that natural log right there. And then eardrum busting at 1 times 10 to the 4th. So we want to know how many decibels that would be. So in this case, you're doing the beta of 10 to the 4th, which is going to be 120 plus 10 times log of 10 to the 4th. Again, you can use the calculator for this, but it's pretty easy to do without the calculator because the base on that log is a 10. It's going to cancel. And you're going to have a 4 right there. And then 120, that's going to be 120 plus 40, which gives you 160 decibels. There, so at 160 decibels, your eardrum could burst. But we could also have gone over here and do x equals 10 to the 4th. One of the problems with that, x equals 10 to the 4th, you're going to have to zoom out like so far. You have to go over here and make your x-axis go to like 1,000. No, 10,000. Yeah, there we go. Mm-hmm.
So like to answer that, like without, like do you just leave it as 160 dB, or do you like put B 10 to the 4 just 160? Or does it matter?
I think it would just be okay to say 160 decibels right here. All right.